Alright, now that you know how to do matrix multiplication, we can check to see if two matrices are inverses by multiplying them together. If they're inverse of one another, you should get the identity matrix. So for a 2 by 2, when we multiply it by its inverse, we should get the 2 by 2 identity matrix, which is a 1, 0, 0, 1. If we have a 3 by 3, when we multiply by the inverse, we should get the identity matrix that has the 1s in the main diagonal and 0s everywhere else. So we're going to check these real quickly to see if they're multiplicative inverses. So if we try part A, we're going to multiply the first row by the first column, and we should get ourselves another 2 by 2 matrix because you have a 2 by 2 multiplied by a 2 by 2. So we're going to do 1 times negative 2 and add that to 2 times 3 halves. And so you get negative 2 plus 3 is a positive 1. Then we're going to do first row, second column. So row 1, column 2. So you have a 1 times 1 plus 2 times negative 1 half, which gives you a 1 minus 1, which is a 0. Now we're going to go to the second row, first column. So 3 times negative 2 plus 3, plus 4 times 3 halves, which gives me 6 plus 6, oops, I forgot couldn't see my negative. So we have a 3 times negative 2 is negative 6 plus positive 6 gives me a 0. Then we're going to do the last row times the last column. So 3 times 1 plus 4 times negative 1 half, which gives you a 3 minus 2, or a 1. So we get the identity matrix. So here for part A times B is the identity matrix, so they are inverses of each other. And you do the same thing with a 3 by 3. You're just going to multiply all the way out. If they're inverses of each other, you get the identity matrix that's a 3 by 3. And if not, then you won't get that. We're going to move into talking about inverses, but before you can find an inverse, you have to be able to find a determinant. So we have two different types of determinants we're going to find, or we're going to be worried about. And that's going to be for a 2 by 2 and a 3 by 3. So you're only going to be able to find a determinant if you have a square matrix. If you have a 2 by 2, you're going to take the main diagonal, A and D, multiply them together, and then you're going to subtract the product of the other diagonal. When you have a 3 by 3, it's a little bit more complicated, and there's a couple different ways to do it. I'm just going to show you this way, which requires you to copy the whole first column outside the matrix, copy the whole second column outside the matrix. Then you're going to take the main diagonals going this way, find their products and add them together, and then subtract the sum of the other diagonals going the other direction that are all added together as well. So we'll start off with a 2 by 2. If I want the determinant of this, I'm going to do 3 times 5 and subtract 2 times negative 1. So 3 times 5 is 15, minus negative 2 is plus 2, which gives me a determinant of 17. Right. The next one is my 3 by 3. So I'm going to copy the whole first column. I'm going to copy the whole second column. Then I'm going to multiply the main diagonal and then the two diagonals next to it. All those are going to give me the sum for the first part. So for the first part, I have 1 times 4 times 2, which is an 8. Added that to 0 times negative 1 times 3, which is just 0. Added to negative 2 times 0 times 5, which is also a 0. Then I'm going to subtract the sum of the other diagonal. So we're going to go the other direction. We're going to do this diagonal and then the two adjacent to it. So 3 times 4 times negative 2 is going to be negative 24. 5 times negative 1 times positive 1 is negative 5. And then 2 times 0 is 0. So in the first set we get an 8, And then we have minus negative 24 minus 5 is negative 29, which gives me a positive 37. So the determinant for part B is 37.